So let's go and create, remember it's standard Iam 4mm. Create. So as that's creating, I just want to see, what do they say should be the place the valve body as the grounded part. As you can see here, the valve body should be the grounded part. Always make sure you make sure that you know which part needs to be grounded, so that it doesn't move as you do your assembly. So this was the some body. Okay, there we go. Right click, place grounded at origin. So there's that part. And now we can add our other two pieces. Our handle and clip IPT. Okay, now we can go ahead and start assembling our thing. So we want that in here, like that. Okay, and we apply that. So this is able to move in anywhere in that. That degree of freedom is basically taken away. Can only move up and down in this direction. Then we want to constrain the face of this to this face over here. Sorry, wrong. That's the wrong face. We want to constrain this face over here to this face there, like that. Apply that. So now we can see it can only rotate like this. We will constrain this later on. Now let's go to now we can constrain this clip to this piece of the clip groove. So the way we can do that is click on the axis that runs through there to this axis over here. It will constrain, and then we want to make this a tangent to this cylindrical groove. So the way we do that is click on tangent. Okay, before we do that, let's just pull it out so that it's easier to work with, something like that. We can click on tangent, click on this piece, and we'll click on this piece over here. You can choose either this top piece, or it's a bit difficult to see, or this bottom piece over here. Right, doesn't really matter. It should fit snug like that. It's not that, it's that one. And then you click apply, and that should be, if we look at it straight on, that should be perfect like that. So this is still able to rotate around there. The last thing, if I'm not mistaken, the clip is on. We need to constrain the handle. So the way we're going to do that is use, as they say here, constrain the handle to be at a 45-degree angle with the valve body as shown below. Okay, so we go here and we now go to the top view. We want to constrain this handle to this edge over here at 45 degrees. So we can do this. We can click on constrain, go to angle, click on the first option. This is, I forgot what it's called, directed angle. Okay, then if we just click on this edge, click on this edge of your handle, because that is what you want to constrain. You could click on the other edge, but then it's taking a whole other angle you'd have to measure right around. And then you click to this surface, right, and then just put in 45 degrees. So if you look at it from the top view, then that is how your handle will be constrained. Is it? Define set. No interference was detected. Okay. So the interference tool is basically for you to see if you had to actually build this in real life, would there be any like edges overlapping, or something that's not in place, is something rattling or something like that. So if there is an interference, then you know there's probably something off. Like for example, there could be maybe this is too thick and it's going inside the valve body, so it won't fit properly, or this clip is too big and it's not gonna secure the valve handle into the valve body. So that is basically the analyze interference. Is basically for you to see if something is wrong with your IPTs. So for this one, we saw that if we click on interference analysis, we can click on that, click on all these pieces and check, and it will come up. There were no interferences detected. So we know that this is a perfect IAM or assembly part. Everything fits perfectly. It will work. Now we need to go ahead and do the IDW for our assembly. So the way we can do that is if we start with this is, let me just save this quickly. This is assembly for week 6. Don't forget to add your student number as well. That's week 6. Okay, perfect. Okay, now that we have the our front view, we need to do a section view so that they can see each part of this, right? It's a bit weird to see that we're going to have a section view if the section view goes straight down the middle. Let me rather do it, then we can have a look at this. It's going to look a bit weird, right? So from there straight down, if you can see, there's an ellipse, right? Because the circle or the whole of the valve handle is not in line with the whole of the valve body, so that looks a bit weird. And we're gonna have so I'm gonna add a second view just to be safe. I'm gonna add a second section view like that, and I'm gonna drop it over here. So this way we have two section views, right? And this one shows us everything that's happening over here, and this shows us the clip groove as well as the entire handle. If you click on assembly for this one, and then you click on the handle, right, and go to section participation and click on none, it will look like this. So I'm going to leave mine like this. I'm not sectioning the handle here because you have a part of the handle that is sectioned over here. So in this case we can see the actual valve body, and we can see the clip groove, the clip itself on the clip groove. On this part we're able to see the valve body, the hole through the valve body, and we're able to see part of the part of the handle. So that's how I'm going to do it. Here what we can do is if we edit this view and we take out hidden detail, then we have something like this, and we're able to see all the hidden detail that we need to in this views, right? Once that is done, we can add the parts list. This would be the assembly. Okay. Also don't forget to add your drawing symbols. So it will be this one over here, that will be fine. If you're confused about exactly how to do this, you can refer to week 5. As you see in week 6, they say complete the formal drawing as you have learnt in week 5, step 12. So if you go to week 5, you can always refer to this. If you're confused, they give you a full rundown on how to we don't do dimensioning particularly on our assemblies, so we just give the part, and we give a balloon to each part, and we say what that specific part is with material specifications. So they give you a full thing on numbering system on how we do this on this for a assembly for an assembly, so you can run through that if you're confused. As you can see, there's no particularly dimensioned parts over here. There's just the balloons and each part, and in the parts list it states what that part is. So yeah, that is how I'm going to do it over here. You can complete all of this. Obviously, if you're not sure, take a balloon to each part. That will be part 1. This one can be part. There's 3 parts over here. There we go. So remember that each number has to be different. It doesn't matter the order of the number, they just have to be different, because one part, as long as each part is not the same part, then it has to have a different number. So example, meaning that this handle, the valve handle, is not the same part as the valve body, so it needs to have a different number to the valve body, even though they are one assembly. And then you can just go ahead in the parts list. If you click on parts list, this will come up, and you can now add in all your details over here. So for example, part 1 will be the valve body, right? And then part 2 is the valve handle, and part 3 is the clip. Right, your material specifications, you can just do EDC engineering drawing CAD 123/week 6/01, depending on which part it is. So for example, part 1 will be EDC 123/week 6/01, right? And then you can do the same for your EDC 123/week 6/02, and then this will be EDC 123/week 6/03. These numbers are just basically what the part is. So if we apply this, you'll see it pops up here. So there's no need for you to specifically go and click on text and then place each part in there. It's just a bit of a waste of time when you can just click on parts for the parts list, and then just add all your information one time. The only thing you'll need to text is all your information in the bottom over here, your scale, your units, your date, all of that kind of stuff, and that should be your IDW for the assembly done.